Good morning, students. Electrostatics, study of stationary charge. Chapter 1, electric field and electric charges. Chapter 2, electrostatic potential and capacitors. Over. Now, we have completed electrostatics. Now we will study current electricity. What do you mean by current? Current means flow of anything. Here, what is meaning of current electricity? Current means flow of, electricity means electric charge. So here, current electricity is branch of physics which deals with charges in motion. Charges in motion, flow of charge, or we can say current. Okay, so see, chapter 3, current electricity. Current means flow of, electricity means electric charges. So current electricity is nothing but flow of electric charges. And yes, flow of electric charges constitute electric current. So what is electric current? What is steady current? What is average current? We will find. See, what is electric current? Here we have one conductor. Here we have one conductor. Okay, it is cross-sectional area of a conductor. We know what is configuration, okay, of conductor. In conductor, valence electrons, according to thermal energy, becomes free. Such free electrons are free to move in random direction according to their energy. During their motion, they collide with positive ions, another electrons, attractive forces, repulsive forces. Their velocity continuously changes. Their velocity continuously changes. Okay, so yes, there are flow of charges. Okay, now here we have to assume one situation. See, imagine a small area held normal to the direction of flow of charges. Small area held normal to the direction of flow of charges. Charges are flowing in this direction. Okay. Positive and negative charges, suppose they are flowing in forward and backward direction. See, it is one general theory. We know that in conductors only negatively charged electrons move. But if positive and negative both charges are moving, then what is for general theory? See, if in this object positive and negative both charges are flowing in forward and backward direction, in forward and in backward direction. Okay, positive and negative charges are moving. Okay, let we give some time interval. We take some time interval. Okay, I am taking time interval from now to after 5 minutes. So in this 5 minutes I have to observe. In this 5 minutes I have to observe the need amount of charges flowing from this area. Flowing from this area. Suppose in a given time interval Q plus be the total net positive charge that flows in forward direction. Yes, this positive and negative charges, they are moving in forward, backward direction. Okay, yes, we have to observe and let net positive charge flowing from this area in forward direction is Q plus in forward direction. Similarly, let Q minus be the net negative charge in forward direction. Okay, Q plus be the positive charge, net positive charge in forward direction, and Q minus be the net negative charge flowing in time interval t. Okay, so what is net amount of charge flowing in forward direction from area in time t? It is Q is equal to Q plus minus Q minus. So what is this Q? Q is net amount of charge flowing in time t. Q is net amount of charge flowing from this area in time t. Then steady current I is equal to Q upon T. Then steady current I is equal to Q upon T. Current is equal to charge flowing per unit time. Current is equal to electric charge, net amount of electric charge flowing per unit time. Charge flowing per unit time. What is meaning of steady current? Steady current means flow of charge remains constant with time. Flow of charge remains constant with time. Okay, at each and every time from this cross-sectional area, same amount of net charge is flowing. Same amount of net charge is flowing. For example, At time t is equal to 1 second, total net charge flowing is 10 coulomb. At time t is equal to 5 seconds, 10 coulomb. At time t is equal to 15 seconds, 10 coulomb. Then if net charge is flowing, the value of current will be same. Means flow of charge remains constant with time. But if with time from this cross-sectional area charge flow of charge is different. Okay, if initially from this cross-sectional area 10 coulomb charge is flowing, then after some time it is 15 coulomb, after some time it is 25 coulomb. Okay, then if charge flowing from this cross-sectional area continuously changes, then yes, current also changes. So see, currents are not always steady. Whenever charge is flowing from any area changes with time, we have to take some time interval. In that time interval, you have to find charge at each and every time and take its average. So from this time interval, from this charge flowing in some particular time, you can find what is average current. Let in time delta t, amount of charge flowing is delta q. Let in time delta t, amount of charge flowing is delta q. Then average current I is equal to delta q upon delta t. Amount of charge, average current I is equal to delta q upon delta t. Yes, it is average current. It is average current, means where flow of charge is not constant. Where flow of charge is not constant. Okay. Now how to find current at a time t, means instantaneous current. Yes, you know, if you take limit delta t tends to 0. If you take limit delta t tends to 0, like this, limit delta t tends to 0, delta q upon delta t, then you know this average value is converted in instantaneous value. Average value is converted in instantaneous value. So current at time t, that is instantaneous current, I is equal to dq upon dt. So you have to remember this I is equal to q upon t equation for steady current. When charge flowing in time remains constant, flow of charge remains constant. But when flow of charge with time is not constant, charge depends on time, charge flowing depends on time, then you have to use this equation. I is equal to dq upon dt. I is equal to dq upon dt. Clear about this? Okay. What is SI unit of current? Yes, in 11th chapter 2, units, measurement and dimensions, you have already studied. SI unit of current is ampere. And yes, I can write 1 ampere is equal to 1 coulomb per second. Now see here, I is equal to dq upon dt. So if you are given charge q, you differentiate it with respect to time, you will get current. Okay. Now see one more thing. Here it is. I can make dq as subject. Then dq is equal to I dt. Now what is meaning of this equation? In time dt, charge flowing is dq. In small time dt, charge flowing is dq. So if you want to find total charge, how to find total charge? You have to integrate this. So if you take integration dq is equal to integration I dt. Integration dq means it is q is equal to integration I dt. You have to remember this equation. See what is difference between these two equations? If you are given q and you have to find I, differentiate with respect to time. If you are given I and you have to find q, integration with respect to. Clear about this? Okay, so if you are given q, you can find I. If you are given I, you can find q. Clear about this? So it is basic about what is electric current. Okay students, now next topic is electric currents in conductors. Yes, We know that current flows from conductor easily. What is reason? That we will discuss here. Okay. Yes, currents are flowing from conductors, from electrolytic solution, from semiconductors. But in this chapter, we will study electric currents in conductors only. Okay. Yes, you know one concept. See, when an electric charge will experience a force if an electric field is applied. Yes, you know this. Okay, if electric field is in this direction, if electric field is in this direction, you know that positive charge, force acting on positive charge is in direction of electric field. Force acting on negative charge is in opposite direction of electric field. If this positive and negative charges are free to move, if they are free to move, so they will move, and these charges in motion will constitute electric current. Clear about this? So what is concept? See, an electric charge will experience a force if an electric field is applied. If it is free to move, it will thus move, contributing to a current. Clear about this? Now, in this chapter, we will study about conductors. Okay, in conductors, how electric current is formed. You know what is configuration of conductor. In conductor, in atoms, negatively charged electrons in valence orbit, due to thermal energy, they are escaped from atom, leaving behind positive ion, and they become free. Such free electrons, due to intermolecular forces, interatomic forces, okay, due to attractive forces, repulsive forces, they will move in random direction, and they will collide with another particles. They will collide with another particles, another molecules. Okay, and due to their collision, their direction, their velocity is continuously changing. Their velocity is continuously changing. In short, these negatively charged electrons are moving in random direction. These negatively charged electrons are moving in random direction. Okay, see here. In solid conductors, the current is carried by negatively charged electrons. How? We are taking first case, case 1. No electric field is present. In such case, at a time, there is no preferential direction for velocities of electron. Yes, we have discussed. In conductor, when no electric field is present, negatively charged electrons, they are moving in random direction. Electrons are moving in this direction, in this direction, in this direction, in this direction. They are moving in random direction. They are moving in random direction. Clear about this? Clear about this? Okay. So, when no electric field is present, electrons are moving in random direction. They have no preferential direction. In all directions they are moving. So, on an average, we can say number of electrons traveling in any direction is equal to number of electrons traveling in opposite direction. For random motion, we can take probability. Okay, suppose from this cross-sectional area, number of electrons moving in this direction, they are equal. Clear about this? Because due to random motion. So on average, number of electrons traveling in one direction is equal to number of electrons traveling in opposite direction, and therefore there will be no net electric current. If you have one aluminum bar and you hold it, if you have one steel bar and you hold it, will you experience any current, any shock? No. Why? Because electric field is not present. Clear about this? But what happens when the same steel bar connected with wires and switch is on? Yes, you will experience electric shock. So why? See, what is reason? Case 2, when the same conductor is placed in electric field. Now, how electric field is present? See, it is the same conductor, one cylinder. It is its cross-sectional area. Yes, inside conductor, negatively charged electrons are free to move. Negatively charged electrons are free to move. They are moving in direction. Now, we are taking two discs. One disc is positively charged and placed at one end. Another disc is negatively charged and placed at another end. Clear about this? The same conductor that we have discussed in case 1. The same conductor that we have discussed in case 1. But take two discs. One positively charged, one negatively charged. Positively charged at one and negatively charged at another end. Then you know that due to this stationary charge distribution, electric field is produced from positive plate towards negative plate, from positive plate towards negative plate. Now, due to this electric field, see, an electric field is created. Electrons will be accelerated due to field towards plus Q. In initial case, electrons were moving in random direction. But in this case, due to electric field, electrons are moving in this direction. Electrons are moving in this direction. Clear about this? Clear about this? Okay. Electron will be accelerated due to field towards plus Q. They will move thus to neutralize these charges. Yes, electrons will move, electrons will move, electrons will move, and they will neutralize this plus Q charge. See, electrons are moving from this cross-sectional area. Electrons are moving in only one direction, only one preferential direction, only one preferential direction. Okay, yes, electrons are only moving in one direction, only moving in one direction. Clear about this? So yes, in this case, due to motion of electric charges in one direction, net electric current is found. Net electric current is found. What is difference between these two cases? In first case, no electric field. Electrons are moving in random direction. So from any cross-sectional area, electrons are moving in random direction means numbers of electron moving in one direction is equal to number of electrons moving in opposite direction. So total current is 0. But in this case, electrons are moving in only one direction. Electrons are moving in only one direction. So here net electric current is found. Here net electric current is found. And yes, this current will be for very short time. Very short time means once these electrons neutralize this positively charged disk, current will be 0. Current will be 0. But because again, if there is no positive charge, this electron will perform random motion. And random motion means current will be 0. Random motion means current will be 0. Clear about this? Clear about this? So you have to understand what is difference between these two cases. Okay? Electric current is formed. Electric current is formed due to such external electric field. Due to such external electric field. Yes, this external electric field is for short time. So current formed is also for short time. Now if you want current, steady current for a long time, then what you have to use? Yes, you have to use cells. Cells are used. That we will discuss in this chapter. What is cell? How cell works? Okay, that we will discuss in this chapter. Yes, in this chapter we have to deal with electric currents in conductor, but we will also study in next chapters. In conductor, current is due to free electrons. In electrolytic solution, it is due to positive and negative ions that you have, I think, studied in chemistry. Semiconductor, electrons and holes. See, here in conductor, current is due to free electron. In electrolyte solution, it is due to positive and negative ions. And in semiconductor, current is due to electrons and holes. That you have to remember. Clear? Pause your video and write down from board.